Now, we want to talk about the domain and range of the toolkit exponential function, which we just what we've got here. And of the base, of the reciprocal function, okay? Toolkit reciprocal function, the basic toolkit exponential function. So let's make sure we've got the word exponential, and I'll abbreviate it. Basic toolkit exponential function is just a set, and the domain is the set of x values. So I'm going to circle the x values. -2, -1, 0, 1, and 2. And I can say the domain now is the set -2, -1, 0, 1, 2. It's a set of x values. The range is the set of y values. So I can circle the y value. And the range is and I'm starting to write out the domain. And I'm not paying attention. Start again. Here's the range. Set 1/4, 1/2, 1, 2, and 4. That's the set of the y values. And I'm not sure if a bit of that is visible, but I think got the idea. Okay, yeah. So there we go. Okay, well, what about the extended exponential function? Extended toolkit exponential function. What's the domain of this function? What's its range? The domain is a set of all the x values. What are the x values? Corresponding to points of this curve. Well, we could actually, a series of points in this curve, we can draw lines down to the x-axis. And we see that those lines tell us that the x coordinates of the points start at -2 and end at 2. And include all values in between because this curve has no breaks. So there are no breaks in the set of x values. Okay. If there are no breaks in the curve, if there's a break in the x values, then there wouldn't be a point above it. There's always a point above every point between x equals -2 and 2. So that the domain of the extended toolkit exponential function is okay. Now, how do we denote this? And this notation you should be familiar with. It's not, if not, it's not difficult to understand. It's the interval the X interval from -2 to 2. And that's exactly what I indicated here. We use brackets, a square bracket on each end to indicate that -2 is included in the domain and 2, with the square bracket there, is included in the domain. Well, there's our domain. Now, what's the range of our extended exponential function? It's a set of all y values. So the range so what is it? Well, we can take the green chalk and start drawing lines and points of the toolkit from the over to the y-axis. We see that the highest value is 4 and the lowest value isn't 0, it's 1/4, right? So right there, y equals 1/4, right there's y equals 4, and again, every point between is in the range. Okay. So it's the y interval 1/4, 4. Meaning we start at 1/4, including 1/4 as in the square bracket, and we end at 4, and we include 4 because of the square bracket. Okay, so there's your domain and range for the basic toolkit function and the extended toolkit function. There's a complete toolkit function. And we're not going to talk in detail about it, except just to say that this trend is going to continue, no matter how high you want to go, you can find an X value that'll get you there. Also, no matter how close to the y-axis you want to get, you can find an X value that gets you there. But you never do get to the y-axis. There is no power of 2 that's equal to 0. It's always greater than 0. So you have an asymptote to the x-axis here, and you just take off very rapidly into the wild blue yonder as you move this way. Okay. Now, just rearrange these boards. I'll pause the video for a second. Okay, now we have the basic toolkit reciprocal function. We're going to smudge a little bit, but I think you can still read everything. The domain of the basic toolkit reciprocal function consists of -2. Let's make sure we can read that. Okay, again, the domain is a set of X values. We just circle the X values. There we have domain. Is the set -2, -1, -1/2, 1/2, 1, 2. The range is the set of y values. So let's just look at those real quickly. Okay, now we want to put these numbers in order from least to greatest. Okay, -2 is the leftmost number in the set, so we're going to write -2 first. And then we have -1 and -1/2. And then we have 1/2 and 1 and 2. By writing them in order, it becomes obvious that the domain and the range are identical. Now that has implications, turns out the function its own inverse and stuff like that, but we're not ready to talk about that at this point. So for the basic toolkit reciprocal function, here's the domain and here's the range. Now for the extended toolkit reciprocal function, we're going to do just what we did previously. But use purple chalk, and from every point on the curve, we're gonna set the line to the x-axis. And we find that the x coordinates of the points of the curve consist of all the values from -2 to -1/2, including -2 and -1/2. Now, that's not all, because we have this branch of the curve. And we draw vertical lines down to the x-axis to indicate the x coordinates of those points, and you see that they go from 1/2 to 2. So the domain the extended reciprocal function is what? The interval from -2 to -1/2. Along with the intervals from 1/2 to 2. Two separate intervals. Now, what do I mean if I just write these one right next to the other? I don't know, we're multiplying them. What are we doing with them? Well, what we're doing is we're forming the union of these two sets, because each of these intervals is a set. It's an infinite set. There are infinitely many numbers between -2 and -1/2. And you have infinitely many numbers between 1/2 and 2. So the set of numbers over here, the set of numbers over here, each is a set. We put two sets together into one, we do their union. Now, this is, again, something that you should know from prerequisite courses, but it's not always the case. This means the union of these two sets. It means that X is in the domain if it's either in here or here, which it can't be in both. So if X is equal to 1.2, well, that's between 1/2 and 2, so it's in this one. If X is equal to -0.9, well, that's between -1/2 and -2. It's in this one. It's in this set. So there's two numbers, both of those numbers, 1.2 wasn't, and -0.9, whatever they were. One is in this set, one is in this set. Each is in the domain. It only has to be in one of these sets. All right. If we get the range, which is a set of y values, we can draw a bunch of lines over here. We'll see that our y values can go from -1/2 to -2. And over here, go from 1/2 to 2. So the range is turns out the same as the domain, which shouldn't be a big surprise, because the domain and range of the basic toolkit function turned out to be the same. In that case, there's our right. And that's all we're gonna say right now about domain and range, but it's an idea that we're gonna continue to develop.